Children, so now onwards I am discussing an extraordinary concepts, okay? So which was very important in our real time, very important in our real life. So I will discuss at least 3 different concepts here. If you look at this, I'm giving you 100% assurance that you will understand this kinematics chapter up to a maximum extent. No doubt in that. Let me tell you one thing. There is a building or a tower of height h. From the foot of the building or from the foot of a tower, your friend is throwing a ball, right? He has to apply velocity u. Then only he can throw the ball in upward direction. Now you yourself, you are standing at the top of the building, that is on the terrace, and you are simply releasing or dropping another ball. So what happens? If these two balls at some particular time, they will meet each other. You can say they both are colliding each other. So my question is that what is the time taken for the balls to meet each other? Or that is first question. Second question is that what is the distance of that particular point from the ground? Once again repeating, what is the distance at which they meet each other, either from the ground or from the top of a tower? Like that the questions will be there. For example, third question, what will be the velocity at the time of meeting or at the time of colliding for both the bodies? What is the velocity of the first body and what is the velocity of the second body when they collide each other? Clear? And fourth question, suppose if I assume that the first body velocity is double of the second velocity or second body velocity is double of the first velocity, then what will be their times? Each other times. Okay, so like this we will be discussing many things. So now let us write those concepts. Okay, thing is that one body is thrown in upward direction from the ground, that is from the foot of a building or foot of a tower, and other body is released or dropped from the building of height h. So at some particular point of time, they both will cross or meet each other. So that is our target. What is that point? What is the distance of that point? And what is the time at which they meet each other? And what is the velocity of both the bodies? These are the things we are going to discuss. Okay. Let me write that. A body is projected vertically upwards from the foot of tower or building, either from foot of tower or building, or you can say from the ground, like this. A body is projected vertically upwards from the foot of a tower or building or ground, okay, with some velocity u, and simultaneously other body, look here what I am writing, other body is projected, or instead of saying, let me say, is dropped from the top of the building. Remember, dropped from the top of the building. Okay. So simultaneously two bodies, one is from the ground of the building and other one is from the top of the building, are thrown. Now my question is that now both the bodies collide each other or meet each other. Bodies collide, or let me say meet each other. So this is what happening in this particular concept. Okay. So as per the given concept, let me make you understand. There are two different bodies. One is projected upwards from the ground, and second body, means other body, is dropped from the top of a building. So only these two cases I am telling you, but I am not asking you what to find. Clear, na? So let me draw what else. From the given data, I will draw something, and after that, we will discuss what to find. Okay. So, this is a building, or I can say tower. Like this. So, from the top of the tower, so this is top. So, one body, let me say this is first body, drop now. So, let me represent it by dotted lines. Let me represent this dropped ball. So, previously also I have done the same thing. If it is dropped, I have to put dotted lines. Okay. So, let me write here dropped. So, initial velocity of the ball is 0. Drop concept. When it is coming down, acceleration equal to plus g. Like this. Now, I told you that there is other body which is projected from the ground, base level. So, here there is other body. Let me write here as 2. And this is thrown from the ground. So, when it is projected upwards, it is having some velocity. So, velocity of this second body, let me assume it as u. Since it is going in upward direction, we have to say that it is having some acceleration. So, acceleration is equal to minus g when it is going in upward direction. These are the first two assumptions you have to be very much clear. Upward journey, it is minus g, and downward journey, it is plus g. Okay. This body has been simply dropped, freely falling. I said earlier, drop or free fall. There is no velocity, velocity equal to 0. And here it is thrown up, there is some velocity. So, like this, you have considered two different cases. Clear now? Now, what we have to do? So, look at this diagram carefully, read the question again and again. Oh, so let me give some notations to this. Let this point be A. Okay, let this point be something like B, and the point at which they meet each other, let me take it as C. Now, by extending this, I can say that this second word is going up and this is first word. So, this is the point at which they are meeting. Meeting point. Or, so now journey or distance, how did I define you? So, height of the building is given as A to B. Okay. So, distance travelled by first body plus distance travelled by second body. So, first body you are taking it as, that is distance. A stands for distance from A to C, whereas this one distance from B to C. So, like this I am taking. Is it clear? So, finally, the distance from A to B is given as distance from A to C and from B to C. Is it clear? So, the total distance is A to C, no doubt in that. The first word is traveling from A to C, so that is written here A to C. Second word is traveling from B to C, that is written here B to C. I hope you understood this. Okay. Now, separately let us calculate what is the distance of A to C and B to C. Look at this diagram carefully. So, this is first body. Okay. So, this is point A and I assume that this is point C. So, from here to here, if I wish to calculate A to C, ut plus half A t square as per the given data. Okay. At point A, so at point A the velocity is 0. So, this is 0 plus half. While it is coming down, I told you that the acceleration is plus g. So, g and time taken here it is t square. So, distance from A to C is equal to half g t square. Okay. So, this is what the distance travelled by the first body. Now let me consider second body, this second body, okay. So for our easiness, I am drawing in on other side, okay, just for to make it easy. So this is second body. I assume that this is point B. Second body is going in upward direction, isn't it? Now this point is C. So now I am interested to find out this distance, that is from point B to C. Clear? So what I could say, you know the velocity at point B. What is the velocity at point B? Take it as u. Whereas the acceleration is minus g in this case. Okay, let us substitute this. So s is equal to, let me write here, ut plus half at square. You are saying from B to C. So this is B and time is from B to C. Okay, here both time is same because both are happening simultaneously. So no need to say again time. So for acceleration you can write BC. So this is acceleration from B to C. And whereas this is acceleration from A to B. Acceleration from A to B. Clear, no? So what was there here? Velocity at point B is u and t. Whereas the acceleration is negative, minus is there. So minus half gt square. So like this I could write. So this is what is the distance travelled from B to C. Okay, my dear children. So now I got this two distance. Now it's time to substitute here. So the total height of the building, that is from point A to B, let me take it as height of the building as h. That is the distance from A to B. We could assume like that. So this is h, which is equal to A to C. I have given it as half gt square. So this is the place where I have discussed distance from A to C. And here B to C, that is ut minus half gt square. So plus half gt square minus half gt square. So u is equal to u into t. Clear enough? Now our interest is to find out this t. So how to find out this t? H is equal to ut means h by u equal to t. No doubt in that. So what is this t? H by u equal to t. So what is this t? So in this every case what I am saying is that t is nothing but the time taken for the first body to move from A to B, and similarly the time taken for the second body to move from B to C. So the time is same because both of them are projected simultaneously. So what I have to say is that this is the time at which both are meeting or colliding. Very important question, my dear children. So if anyone asks you, if two bodies are projected simultaneously in opposite directions, so in that if the first body is dropped or freely fallen and second body is projected from bottom of the tower or from the ground, so no doubt they both will meet at some particular point. So at that point, what is the time taken for meeting, or what is the time taken for collision, which was given by the formula h by u. Just remember this, okay? Very important concept. Here t is nothing but time taken for both the bodies to meet each other. Is it clear? Is given by t equal to h by u. Very important concept, my children, my dear children. So have a close look at this. I have just found out only one case, that is time. So next one I am going to find out at what distance from the ground this is going to happen, or at what distance from top of the tower it is going to happen. So that is next case I am going to discuss. So have a close look at this. I will give you some time and after that I am going to erase it. Okay. Okay, my dear children. So initially in the first case we have studied the time taken to meet each other. Okay, nothing but t equal to h by u, where h stands for height of the tower and u stands for velocity with which the second body has been projected upwards. Okay. Now in next case is that we have to find out the distance or height at which both of them meet each other. Okay. So height in the sense we have to measure height from bottom or from the top. I say that your height is 5 feet. So how you are measuring it? Nothing but from the ground only, no? From the bottom only, no? So here also I want to find out the height at which both the bodies are meeting. So this one. So this bottom part is nothing but from B to C, isn't it? So point B to point C is nothing but the height at which both the points are colliding. Both the bodies are colliding, right? Height at which collision takes place. This is what you have to find. You have to say meet or collide. Right. So from bottom you have to take, right? So that is S. From point B to C it is happening. B to C. Already you have data, that is ut minus half gt square. Ut minus half gt square. So SBC is equal to ut minus half g into t square. What is the time of collision? That is equal to h by u. So better substitute that now, so that we'll get the distance also. U into h by u minus half g h by u whole square. So u cancelled, h minus g into h square by 2u square. So this is what is SBC. SBC, that is distance from the ground or from the bottom of the tower to point of collision. So we can call it as the height at which this collision is taking place. Okay. Now point number 3. Distance from top of a tower or distance at which collision takes place from top of a tower. Okay. So from top it is A and to C it is collision is taking place. So A to C. So I told you A to C half gt square. So what is this t? H by u. So at this particular h by u time this collision is taken place. So you could write it as gh square by 2 times of u square. So this is what the distance from the top of a tower at which the collision has been taken place. Okay. So look at this, whatever I have written, and understand it carefully. So the last point that we have to find is that time. Time after which their velocities means after some time. It's not initial velocity u, after some time means after some t seconds, v equal to u plus at, v equal to u plus at, right? So the time after which their velocities are equal in magnitudes. The time after which velocities are equal in the magnitude. So we have to find out the time at which both of their velocities are equal. That is what is the question. Time at which both of their velocities are equal. Initially you have found out the time of collision, not the time of their equal velocities. So here from the diagram, this meeting point, right? So at what time these velocities are equal? This is what is the question. So after some time, this velocity will be VA, and for this body after some time the velocity will be VB. So the answer is in the question itself. He is saying that velocities must be equal. Velocities must be equal. Which velocity? After some time. So if velocities are equal, right? Find out the time at which it will happening. Find out the time at which it is happening. That is what the question. Find the time at which the velocities are equal. Which velocities? After some time. So that is what the hint given in the question. Okay. So the velocities of first body V1, or you can say VA, is equal to V2. Okay. Here VA is nothing but velocity of first body. VB is nothing but velocity of the second body. At what time it is happening? So look at the diagram carefully, my dear children. Here itself I would like to derive it. Okay. So you are saying this is V1 and this is point of starting where u1 or ua equal to 0. Okay? Equal to 0. Since it is coming down, acceleration is plus g. You are having some equation v equal to u plus at. So here u1 is nothing but 0 and a1 is nothing but g. We don't know the time. So it is t. So v1 is equal to 0 plus gt. So here this v1 is gt. This is what I could tell you. Okay. So that is the velocity of the first body after t seconds. Now let us discuss about the second body. I am writing on the other side, okay, just for easiness. So here initial I told you that initial of second body is u2. Then what is v2? What is v2? Here one more error is that the body is going up, so acceleration is minus g. So what is v2? So again the same formula. v2 is equal to u plus at. So this is 2 and this is 2. So u minus gt. Okay? U minus gt. So now velocities are equal and time is got. We have written this velocity in terms of time, and our interest is to find out the time at which this is happening. So this minus gt comes this side, so it is 2 gt is equal to u. So from this, you could say that time t equal to u by 2 into g. So this is what the time at which their velocities are equal. Understood, my dear children? So the answer is given in the question only. When the velocities are equal, you find out the time. That is what is given. So v1 is equal to v2 as per the given question. Now at this point of time, what I have done is that simply I have substituted its values and found out the time where the velocities are equal. Is it clear?